The next thing on our list is going to be detecting when the pig overlaps these apples. So we're going to need to create an apple scene so that we can attach a collision shape to the apple as well. So let's delete these. If you select up here and then hold shift, you can select all your apples at once and delete them. Goodbye, apples. We'll create a new scene, and there's a quick icon for that right here. We can click on. We want to make a custom node. Our apple is also going to be an area 2D node, just like the pig. Gonna rename it apple. We will attach. If you look at recent, you can often just use the recent. We'll attach a collision shape 2D. We'll just call it collision. And we'll give it a shape. Oh, but we want a sprite on this apple. So click on apple. Drag over the apple. Set the transform on the apple to 0, 0. We'll scroll to zoom in a bit here. Drag it up. Well, let's see. Do we have the collision shape on top? No, we've got our sprite and then collision shape. So let's do the same thing. We'll have the sprite and then the collision shape. I want this to be called sprite though, because it's the sprite associated with the apple. We don't want them both to be called apple. Okay. Now we'll need a collision shape, and for the apple, we'll just do a circle. And we can drag this, shrink it down, move it around a bit until it fits nicely. Probably, we haven't ever done this, but we'll probably want to turn on pixel snap. Use pixel snap. I prefer to use pixel snap. Holy cow, that is not pixel snap. That is smart snapping, I think. So we'll turn those off. Oh, it's because we have snap to grid on. We'll turn that off too. There we go. Now we've got pixel snap. So we'll just go down 1 pixel. Looks pretty good. And there. Perfect. We can save this apple scene. Come back into our world scene. We can drag an apple into the world. Drop it over here. Now, if you want to create a lot of an object, usually what I do is Control D to duplicate. Then there's 2 right here. Then just drag it over. Control D, drag. And we can add quite a few this way. And that's probably enough apples for now. Perfect. So we've created our apple scene, made some apples in the room, but we're still not detecting a collision. Well, technically the collisions are being detected. We're not doing anything about it. So if we come into pig right here, there's a few different ways we can do this. You can see if we click on the pig scene right here to come into our pig scene, and we click on node, there are some signals associated with this. So we have area entered and area exited. So we'll actually use the area entered signal. So we can click on this, and just like we did before, we can create a new function on pig area entered. We'll assign it to the pig root node, which will be our script, and we want it to make a function, connect. You can see it's opened up our script editor and made a function down here called on pig area entered. And we get the area as a parameter, an argument. So let's do area.queueFree. Now queueFree is how you destroy a node or a scene in Godot. So this right here, it will take the other area that we collided with, which will be an apple, and it will get rid of it. It will delete it from the scene. And you could say it's, you could also use free, but free can sometimes remove that node before it's ready to be removed. Maybe it's got some more logic it needs to run. Maybe something needs to happen. So that can cause issues. So you pretty much always just want to use queue free, because what that does is it queues it. It puts it into a queue and says, remove these things when they're no longer needed, which is usually at the end of your current frame. So it's not like it's a long time. And we can move around, and you can see when we run into these apples, they are removed from the scene. Okay, so that was really easy, right? Let's talk about the other way to do it as well. So I can show you two different methods for doing this. So the other way to do this is using a code inside of our process function. And it is var areas equals get overlapping areas. Okay, so this function right here is a function inside of our area2D. If you come into here, you can see methods. We have get overlapping areas, get overlapping bodies. These return an array, so it returns a list of areas. So this is what you'll want to use if you basically have multiple collisions that you want to handle, where you're colliding with multiple things at once. This right here will work quite well. I don't know if this will work for multiple collisions. I haven't tested to see how well it would work. I assume it would process them one at a time, but you could use this if you wanted to check how many things you're colliding with, because you could check the size of the array that you get back. Then you would just do for area in areas area.queue free. So this will work exactly like our signal would. But we would loop through every single area that we're colliding with and delete them. That's what this loop does right here. So looping in Godot is actually quite easy, right? For area in areas, this just says basically for each area, and we're just calling it an area. It could be called anything. It could be called for O in areas or whatever. Then we would use O down here instead. But for area in areas, this is an array, so it will loop through every element of this array, do this thing on it. Okay? Pretty simple. Pretty simple. But we're gonna keep using the signal, because I think when you can, the signal's the way to go. It doesn't. It's this right here, this function, the process function runs every frame. This is a case where we can just use a signal for it, and I think it'll be better. Okay, so what happens though? What happens if we have another pig, right? Uh-oh, this sounds like a bad thing, right? What happens if we have another pig over here? We've got two pigs in the game. One of them is actually a child of the second one, so then it's moving twice as fast. So let's drag our pig up here. Actually, you know what? That's actually beneficial for my example, because what I want to show you is what happens when they collide, right? So our pigs are moving along, and then they collide with each other. Boom. They deleted each other, right? Why did they delete each other? Well, they collided. They're both areas, right? So they collided with another area, and it said, oh, here's an area. Why don't you delete that other area? Well, that's not what we want, right? We want to only delete apples, not pigs. We don't want to delete pigs. We love pigs. So we're going to learn about collision layers and collision masks. So if you click on, let's delete the second pig, even though we just said we don't want to delete them. We want to this time. We're making an exception. If you come into collision here on this is a property obviously associated with an area2D. If you come into collisions, you can choose a layer and a mask. Now, when I was first learning Godot, I literally always got these confused and couldn't figure out what was what, right? So hopefully I can help you avoid that problem. The layer, the first one, is the layer that you are on. It's where you are. Your collision is on that. And you can see we can choose multiple ones. You can be on multiple layers at once. But, oops, I accidentally unclicked monitoring. You want to make sure monitoring and monitorable are both on. So you can be on multiple layers at once, right? You can choose which layer you're on. The mask is what layers you are looking at to try and collide with. And you can see currently we're on the first layer, and we're also looking to see if there are any collisions on the first layer. So the first one is what layer you're on. Just remember, the layer is where you are, and the mask is where you're looking at. Okay? We can actually name these. Remember our project settings? Come into project settings, general. Come down to layer names, 2D physics. Up here at the top, our first layer we're going to name pig. Our second layer we're going to name apples. Okay? Close. Then if you come over to our collision again, you can come into here. Oh, there's still only layer 1 and layer 2 if you click on this little thing. But I found that if you click off of it and then click back on, that it updates, and we've got pig and apples. So we're inside of our pig scene. Let's click on our pig scene actually. Make sure we're inside of the scene here. Because if we change this right here, it will just change this instance of the pig. It won't change all pigs. We want to change all pigs, which will be inside of the pig scene right here. So we'll click over here, and we'll set it to the pig layer. But the pig is only going to be colliding with apples, so we don't want to look at the pig layer. We don't want to detect the pig layer. We want to detect the apples layer. Okay? We want to look at the apples layer and be on the pig layer, right? First one's be on. The second one is look at. Okay? Now if we come back to apple here, our apple scene, we come to collisions. You can see the apple is currently looking at the pig layer and is also currently on the pig layer. Well, we want the apple to be on the apples layer, but not on the pig's layer, because it's an apple, so it goes on the apples layer. And then the apple doesn't actually need to detect any other collisions. So we can turn off its mask. That way it's not looking to try and detect any collisions. And that will help optimize our code. Now if we come into the pig, well, if we come back into our world and we add another pig as a child of this pig, right? And we run the game, the pigs will no longer delete each other, but they will delete the apples. They will still detect the apples in the room. And so you can use collision layers like this to basically manipulate. If you have coins in your game, you can make a coins layer, and you can have the player look to the coins layer and do something if it detects a collision with a coin, right? But you maybe don't want the enemies to detect coins at all. They don't pick up coins. They just walk through them. And so you would then make sure that the enemy, you would set its mask to not look for the coins layer. And it's a very powerful way to do it. Some people use groups for this. We'll be likely talking about groups later, but groups are another way to go about this, but I think the layer system is a better way to do it. It's more optimized, and I recommend using it instead. So the final thing we're going to do for this section is we're going to make our pig scale up every time it eats an apple. So if you come down into our function on pig area entered, we'll do scale times equals 1.1. This will make the pig scale whenever it eats an apple. We'll run the game, and now our pig gets slightly fatter and fatter each time it eats an apple. And this is just, it's not really that important to do that, but this is my daughter's favorite game out of all of the projects that I made for this course. She loves this game. Both of them, actually, the two older ones. They would play it and they would just crack up every time. We put tons of apples on the screen, so the pig would be like giant, like as big as the screen, and they would just laugh the entire time. Thought it was the funniest thing. And it's an easy game to play, so they were able to control the pig and move it around on the screen and have a lot of fun. It was actually a reminder to me that you don't have to make amazing 3D realistic games in order for people to enjoy them. And so anyways, thank you so much for watching this lecture. I hope you enjoyed it, and I will see you all in the next one.